A 10-speed analog to digital speedometer uses a 555 in a monostable mode and an analog input of a magnetic switch to power a 3914 voltage display chip. First, let's examine the magnetic switch that is used to produce an analog frequency. The switch contains two bipolar leads, and when voltage is applied to both, current can only pass when a magnet is close to the switch. The switch and the magnet are placed parallel to each other on a bicycle wheel. As the wheel turns, the switch closes and opens. This causes an analog frequency to form. The faster the bike wheel rotates, the higher the frequency is formed. This analog signal is then fed into a transistor-capacitor arrangement, which turns the analog signal into a digital square wave. This wave is fed into pins 6 and 2 of the 555 timer, the threshold and trigger pin. The 555 timer should produce a varying voltage output, which then goes to the signal input of a 3914 chip. This voltage output is directly affected by the speed of the wheel. The faster the wheel moves, the higher the frequency, and the higher the voltage output of the 555 timer. The 3914 has a voltage range, and when voltage is applied to the signal pin, a certain amount of LEDs light up that correspond to where the voltage is in that range. This 555 timer arrangement is specifically what I had trouble with when making my ISP. Unfortunately, my ISP is yet to work, but through this experience, I've learned how to source the proper chips and that I shouldn't always rely on virtual schematics to line up with the real world.